Right, question 3. In the diagram below, KLPQ is a trapezium. KL is parallel to QP. So these two lines, they are parallel. And since you have a parallel in these two lines, you should know their gradient for KL and gradient for QP. They are the same. Right? So first, you need to find the equation of the straight line QP. Equation, you need your M, you need your C. Okay? Straight line QP, this is your straight line QP. Again, if you are looking for your M, you should start checking from your QP first. But over here, you can't really use your QP to find the gradient because there's an unknown value under your coordinates Q, right? So indirectly, you are actually trying to look your gradient from the line KL, right? KL, over here, you have a coordinates. And basically, you can get your coordinates for your L. Because your L, you have something with 0, where your X is here, alright? Your coordinates P is 6, -8, which means this is actually 6. And if you were to extend back to your y-axis, this is actually under -8. Which also means your coordinates for your L is 6, 0, right? Then from now you can actually start moving. Start your gradient equation. Gradient QP equals to gradient KL, because you are trying to link these two parallel lines together. And to get your line KL, you are just using your gradient y over x. So you are using 6 minus 0 over -2 minus 6, right? And you should get a 6 over -8. And again, in this case, you can perform some simplification. You should have 3 over 4 negative as your gradient, right? And from here, you need to continue looking for your C by using your M equals to -3 over 4. And again, you can use any numbers, whether or not you're using K or L, you will get the same answer. Right? So if I'm looking for L, I should have 6, 0. And using the formula y equals to mx plus c, 0 equals to -3 over 4. Substitute your 6 here, plus c. And your c, you should get 18 over 4. And you can do your simplification again. You will get 9 over 2. And lastly, remember to put your general equation as y equals to -3 over 4x plus 9 over 2. Right? And basically this 9 over 2 in your graph, this is the value, right? Where that's actually your y-intercept lah. Okay? And for B, you are looking for the value of h. So in order for you to look for the value of h, which is here, you can connect these two coordinates and compare to the gradient you have found in your gradient KL, because they are the same. Okay, and over here, since you have two sets of coordinates, you are going to use your y2, y1 over x2, x1 equals to -3 over 4, right? So from here, I'm just going to write it here. You will have h minus -8 over -6 minus 6 again, alright? y2 minus y1 over x2 minus x1, and these will basically equal to -3 over 4. And you just need to do some simplification again. You will have h plus 8 over -12 equals to -3 over 4. And if you want to make things easier, just follow the usual way. Do some cross multiplication and get your final answer. Okay? So from here, you can just do your cross multiplication. You have 4 multiply h plus 8 equals to -3 multiply with -12. Okay? So 4h plus 32 equals to 36. 4h equals to 4. So h, you are using 4 divided by 4. And basically h is 1.